Alrighty guys, so in this video we're going to talk about how to determine the amount of atoms in a mole for a specific compound. For an example, if I gave you 9.62 moles of water and I asked you how many oxygen atoms are in that amount of moles, you would use this way of procedure to answer the question. Alright, in the last video we talked about just how to figure out the amount of moles. Alright, I gave you guys molecules or atoms, and I said convert these molecules to moles. Then we're going to take it a step further and determining how many atoms there are within a specific amount of moles for a compound. All right, my first example is propane. All right, propane is a gas used for cooking and heating. How many atoms are in 2.12 moles of propane? All right, so notice first off that I've given you how many moles there are, and I've given you the chemical formula for propane, which is C3H8. The first thing you're going to want to do is you're going to take those moles and you're going to convert those to molecules. We want to figure out how many molecules of propane we have within that amount of moles. All right. So we have 2.12 moles. We want to figure out how many molecules that is. So we're going to use Avogadro's number. 6.02 times 10 to the 23rd molecules per 1 mole. That's the first step. All right, those moles cancel out. Now we're left with molecules. Now we're at molecules. The next step we're going to do is we're going to convert those molecules into atoms. Notice that I'm asking for how many atoms we have in propane. I'm not asking for hydrogen atoms. I'm not asking for carbon atoms. I'm asking for all the atoms within this compound. All right. So the next thing we're going to do is convert our molecules to atoms. All right. For every one molecule, there are 8, 9, 10, 11 atoms. For every one molecule of propane, there are 11 atoms. So for every one molecule, there are 11 atoms. All right, those molecules cancel out. Now we have atoms at the top. That's what we want. We're figuring out how many atoms there are. We're at atoms. We're good. Now we just do the algebra. 2.12 times Avogadro's number times 11. At the bottom, all we have are 1, so we can omit those. And the answer will be, let's see, I got the answer over here. 1.39. 1.39 times 10 to the 25th atoms. That's how many atoms we have within 2.12 moles of propane. All right, let's do another example. All right, my next example. How many atoms are in 1.14 moles of sulfur trioxide? How many atoms, total atoms, do we have in 1.14 moles of sulfur trioxide? We're going to do the same exact procedure. We're going to take our moles, convert them into molecules. 6.02 times 10 to the 23rd molecules. That's all over 1 mole, because remember in my last video, we know that 1 mole equals that amount of molecules or representative units, in this case molecules. All right, so the moles cancel out. I notice the question's asking for atoms, not for molecules. So we're going to convert these molecules into atoms. In order to do that, we have to look at the chemical formula. There are 1, 2, 3 oxygens and 1 sulfur. So there are a total of 4 atoms per molecule of sulfur trioxide. So for every 1 molecule, there are 4 atoms. All right. there are three oxygens, 1 sulfur, a total of 4 per molecule. All right, so we're going to cancel those molecules out, and we're done. We got atoms at the top. That's what we want. We want how many atoms. That's the question we're answering. All right, so we can now rewrite it to look like 1.14 times 6.02 times 10 to the 23rd times 4. Denominators are just 1. Plug that into your calculator, and we get a total of 2.74. 2.74 times 10 to the 25th atoms. So what that's saying, for every 1.14 moles of sulfur trioxide, there are a total of 2.74 times 10 to the 25th atoms of atoms within that amount of moles. All right, let's go to the next example. I'm sorry, this should be 24. 24. All right, that's the answer. All right, next example, which will be my last. All right, this one is a little different. All right, and I'll show you how. All right, how many carbon atoms are in 2.12 moles of propane? How many hydrogen atoms are in 2.12 moles of propane? All right, so now instead of me asking for the total amount of atoms throughout this molecule, and I'm asking now for specific atoms. The first one we're talking about is carbon. How many carbon atoms are in 2.112 moles of propane? All right, we're still going to do the first step. The first step is always going to be converting these moles into molecules. All right, so we're going to take the moles. We have 2.12 moles. Convert that to molecules. For every 1 mole, there are 6.2 times 10 to the 23rd molecules. So for every 1 mole, we have that amount of molecules. That's always going to be the same, guys. Remember, if you forgot these things, go back to my previous video to remember how to, understand 1 mole equals that amount, Avogadro's number of molecules, atoms, whatever the case is. All right, so we're going to convert to molecules. The second thing we're going to do is very similar to the last example, except slightly different. We're going to convert those molecules into carbon atoms. So for every 1 molecule of propane, there are 3 carbons. So we're gonna put 3 carbon atoms because that's what we want. All right, so now the molecules are gonna cancel out. Now we're left with carbon atoms, and that's what we want in that first example. It's a little ugly. That's what we want in the first example. All right, so we're going to do 2.12 times 6.02 times 10 to the 23rd, and multiply that by 3, and some number carbon atoms. All right, I'll get the answer right now. That's the first part of the question. The second part is asking how many hydrogen atoms there are. We're going to do the same exact thing, but instead of carbon, we're going to use hydrogen. All right, so we're going to first, again, convert our 2.12 moles the same exact way as we did upwards. All right, at the top, we're going to convert those moles into molecules because we're still talking about propane. Moles cancel out. Now, instead of us converting our molecules into carbon atoms, we're going to convert them to hydrogen atoms. For every 1 molecule of propane, there are 8 hydrogen atoms. 8 H atoms. Molecules cancel out. Now we're left with hydrogen atoms. That's what we want. The algebra looks like this. Now we're multiplying by 8. And that's going to give us some number, and that's going to represent our hydrogen atoms. All right, so if propane looks like C3H8, which number do you think is going to be bigger, the amount of carbon atoms or the amount of hydrogen atoms? Well, there's more hydrogens in one compound or one molecule of propane, so we're going to have more H atoms. All right, the answers are going to look like 3.83, 24, 3.83 times 10 to the 24th. That is for carbon. And for hydrogen, all right, notice that we have 3.83 times 10 to the 24th carbon atoms and 1.02 times 10 to the 25th hydrogen atoms. All right, carbon atoms, hydrogen atoms. We have more hydrogen atoms per one molecule of propane, so it makes sense. Alrighty, guys. I think that's about it. Leave a comment if you have any questions. Like this video so that other students can continue watching these. All right, bye.